In this video, we are going to find the derivatives of implicit equations using the implicit differentiation. So the implicit differentiation used when when the y is given as an implicit function. So first, try to see whether you can find the derivative of these functions, and then you can match your answers with the solutions discussed in the video. Thank you. So take your time and try to find the derivatives first. In this video, we do some practice problems for implicit differentiation. So this is a short version of the video. So try to watch this video after watching the main video about the implicit differentiation and the long version of the practice problems, which discuss more details. So when you do implicit differentiation, we have to remember two things. First, we're going to differentiate both sides of the equation. So that's one thing, because there are two because it's equation, so we can differentiate both sides. Next, we then multiply by the derivative of the inside function. So you know what is mean by the inside function. If you watch the video about the chain rule, that discuss more um, chain rule type problems. Okay, so let's look at the first problem now. Actually, before that, we have some notations that we can use for the derivative of the inside function. We commonly use dy by dx, and also to save time, we use the prime notation. So that's like most common in problems, the prime notation. And also it can be like, let's say you differentiate z variable with respect to, so you have dz by dx. Also, sometimes it's very important in practice problems, like you're going to take the derivative with respect to time. So it's like d by dt. Also, we sometimes use especially when you take the derivative with respect to time, we use the dot notation. So it's like x dot. So those are the common things that we use. This one especially for time variable. So when you take the derivative with respect to time, we use a dot to distinguish it from the prime. Okay, so let's look at the first problem now. As the first problem, we have x3 plus y3 equal 4. So what we do, so you have to say which variable we can use. So we're going to say differentiate with respect to, let's say x. So you have a lot of options. You can say x, y, or even time, like t variable. So let's say x. So if you do that, so we just use the power rule. So we know the power rule. So that means if we have x to a constant, this is simply n x n minus 1. So we're going to use that now. So if you use that, we get 3x squared, and then so that's derivative with respect to x plus, so you can see the next term is not x, so it's a function of y. So what we do, we just take the regular derivative like 3y squared with respect to y, and then we multiply by the derivative of the inside function. In this case, it's dy over dx. So you can see that this is an application of the chain rule. So this coming from the chain rule. So this is chain rule. So since you know, since you watched the video about chain rule, you know clearly what's going on here. So and then we have a 0 on the other side. So if you recall the chain rule, what the chain rule says, if you want to take the derivative of y with respect to x, what we can do is we're going to rewrite this function using a u variable. So it's a dy over du. We take the derivative with respect to u and then multiply by du over dx. So that's the chain rule. So that's exactly what happened here. So here the inside function is y. So this part uh, actually produce 3y squared. And now we can cancel 3 because that's common. So we divide by 3 both sides. So you're going to get x squared plus y squared times dy over dx equals 0. Now we can isolate the derivative term. So what we do, we're going to move the x squared term to the other side. That means we can write this one as x squared dy over dx equal negative x squared, because when you move a term to the other side, simply switch the sign. So that's the easiest way to remember this one, switch the sign. Now we can divide both sides by y squared. So you're going to get dy over dx equal negative x squared over y squared as the derivative. So it's not that difficult. So let's look at the next problem. So as the next one, we have 5xy minus y squared equal 10. So you can see that there's a product here. So that means we're going to use the product rule. So the most common version of the product rule is we can write this one as v u prime plus u v prime. We use this version because you can see that if you look at the quotient rule, you can see it's the exact same top term, only with the slight change you have a negative sign. So that's why we remember that as a product rule. So this is the quotient rule. So this is exact same term but with a minus sign and then v squared. So if you remember this way, it's much easier to remember these formulas. So it's the same term in the numerator with the sign change. That's it. Okay, so we're going to use that here now. So we can say, so we can take the differentiate again as before with respect to x. You have to write it because you have two options here. If you don't write it, it's not clear what you're trying to do. So we write it always with what derivative. Okay, so it's 5, which is a common one. We can take it out and then use the product rule here. So if it's the product rule, what do you get? It is the first term and take the derivative of the second one. So it is dy by dx plus y and then take the derivative of the other term, which is 1. So that's what you get as the derivative of the product. It's always the same. That's not going to change. And the minus, we have a function of y, so we take the derivative with respect to y first and then we multiply by the derivative of y because it's not x. This is a constant, so it's 0. Okay, so you cannot simplify. There's nothing, no common terms there. So what we normally do, we distribute this first. So when you distribute, you can see that you're going to get 5x dy over dx as the first term plus we have 5y equal, and you can see actually I'm going to write the next term. So we have a minus 2y dy over dx. So what we normally do is the next step, normally after distributing, normally what we do, we're going to collect the derivative terms and then move the terms without a derivative to the other side. So that means we can write all of them at once. So normally, like in this step, what will happen is the cancel common factors. So cancel common factors. Cancel common factors. That's like a theoretical step. So we do that here just to simplify this. Cancel common factors. Since there are no common factors in this case, we're gonna skip that step. So what we're gonna do is we're gonna take the terms with derivative. So we're gonna collect them. So we have 5x dy over dx, and then we're gonna move the other derivative term here, and then we're gonna move the terms without derivatives to the other side. So we can write it like that. Now what we're going to do, we're going to factor out the derivative. So that means you're going to get 5x minus 2y. We factor the derivative, it is dy over dx. So we have negative 5y, negative 5y. And then what will happen is you can divide both sides by that factor. So that means you're going to get dy over dx equal negative 5x, 5y over 5x minus 2y. I mean, there's nothing wrong with this one, but you can see there are two negative signs. But if you multiply the top and bottom by negative, you can write this with a less number of negative signs. So I can multiply top and bottom by negative. So you're going to get 5y over 2y minus 5x. So that is much better than the previous one. So we'll write it like that. Okay, let's look at the next one. Before we start the next problem, actually we have a note. So what we normally do is we can use the prime notation. You can use the prime notation to make it simple, because you can, when you use the prime notation, you can reduce the unnecessary writing. So let's look at the next problem with the prime notation now. So we have tan xy equal x plus 7 plus x. So here we have one more thing. We also need to know like when to use the parenthesis and when not to use the parenthesis, and when it is not necessary. So in this situation you have to use the parenthesis, because if you do not write the parenthesis, this may be a different problem. So the problem may be tan x times y. So that's a different problem. That's like y times tan x. So that means this is not equal to tan xy. So you have to be very careful what we really mean by this. So if you mean xy is a single product, it will be better to use the parenthesis here. So be careful like how to use and when to use the parenthesis properly. So you can see this is here we need the derivative of tangent. So let's recall that, and we know that the derivative of tangent is secant squared x. So because of that, so if you take the derivative with respect to x, so you can see it is the secant squared and then xy. We don't take the derivative, we don't do anything with that, and then multiply by the derivative of the inside function, which we already took in the previous problem, which is x, and then take the derivative of the second one, which is y prime, plus y, take the derivative of the first one, which is 1. So that's what you get. So this is the derivative of the xy product. That's the derivative of the xy product. Okay, and then equal, the other side, 7 is a constant, plus 1. Okay, so the next step is we see whether there are any common factors. There's no common factors. So what we do next is we're going to distribute. So if you distribute, you're going to get secant squared xy times xy. So it would be better to write xy in front just to avoid confusion. And then y, we write that in front, secant squared xy equal 1. So what we do next is we're going to move the terms without derivative terms. That means this term to the other side, and then divide by the factor. So that means next step would be x y prime secant squared xy, which is equal to 1 minus the other term, and then we're gonna say y prime equal 1 minus y secant squared xy over, we have x secant squared xy. So that is the derivative you get. So let's look at the next problem now. Next we have 16 equal x squared plus y squared equal square root. You can see this is another way to write the equation of the circle. So so you can see that this is simply you can write this one as x squared plus y squared to the 1/2 power, because derivative means the 1/2 power, square means 1/2 power. What we would do normally is we're gonna square the equation both sides. So squaring both sides, so squaring, we're gonna get square of 16, which is 256, equal, if we square the square root, and we know that it's gonna get cancelled out, square root gonna get cancelled out. So this is what we get, because you can see this is much simple to work with. In the long video, actually we discuss what if you do not do that, and you can see that the expression get a little complicated, but at the end you get the same answer. So please look at the long video about another way to like get the answer without doing it. So now what we can do, we're going to take the derivative with respect to x. So we're going to differentiate with respect to x. So you're going to get 0 on this side because a constant. The other side x squared, which is 2x. And then this is y squared. So we take the derivative with respect to y first and then multiply by y prime. So that's what you get. Now what we want to do is we're going to solve for y prime. This is very easy to solve for y prime. So y prime is, first we're going to move the 2x term to the other side, which is negative 2x, and then divide by 2y. So which you can simplify, cancel into x over y. So that is the derivative of this one. Next we have ln x plus y equal 1. So we need derivative of log. So we know that derivative of a natural log is 1 of x. even with the absolute sign, it's the same thing. Even if you put the absolute sign, it's the same thing. So if you use that, again differentiating with respect to x, just make it a practice. So just to write like better math. So so the inside function is x plus y. So according to the formula, 1 over x plus y goes down, and then the derivative of x plus y, which is derivative of x is 1, derivative of y is y prime, equals 0. And then what's going to happen is there's a 0 on the other side. That means we can, if you multiply both sides by 1 over both sides by x plus y, this term get cancelled out. That means you simply get 1 plus y prime equals 0. This says that y prime equals negative 1. So that's very interesting. So let's look at the next one. As the next one, we have x squared plus 2xy plus y squared equals 4. Again, this is a implicit function with respect implicit function of y. So we're going to take the derivative with respect to x. So if you do that, you're going to get 2x, and then we have the product. So when you do the product, you can consider this as one function, and then y is another function. So that means according to the product rule, it is the first function multiplied by the derivative of the second function, and the second function multiplied by the derivative of the first function. So that's certificate. So that's the derivative of the xy product, and then plus y term. So we take the derivative with respect to y, and then y prime equals 0. What we do next is we can cancel the common factor, which is 2, so we can remove that, and then we're going to combine terms with derivative on one side, terms without derivative on the other side. So if you combine the y prime terms, you can see that you're going to get x plus y prime equal, if you move the terms without x to the other side, you're going to get negative x and negative y. If you factor negative sign, it is x plus y. This is interesting. You can see that if x plus y not equal to 0, you can just cancel that term. Not equal to 0, then you can cancel this term. Because if x plus y equals 0, you cannot cancel because equals 0 equals 0. So that means this what we're trying to do is not valid for any point on that line, which is the line you can see this is the line x y equal negative x, that line. So if you have anything on this line, so this formula is not valid. That's what it says. Okay, so since if this is not the case, we can write this one as y prime equal, you can see that it is negative 1. It's kind of strange, and you get the same answer again, negative 1. So, but you can see in this expression there's no xy terms, so no x plus y term here. So that means there's no issue here. So that means the derivative of this with respect to the implicit derivative is negative 1. And this kind of strange, why exactly happened? And you can see another look at this one. You can see if you factor this actually means x plus y whole thing is squared equal to 4. So if you take the derivative of if you take the square of both sides, you get you can see x plus y equal plus or minus 2. There are two answers. Now if you take the derivative, what will happen? 1 plus dy over dx equal, because a constant, so it's 0 no matter what. So this says that dy over dx equal a negative 1. So that's exactly what happened. So what we did is we put two equations in one formula. That's exactly what happened here. So what we did, there are two equations, but you write two equations as one formula. It's kind of interesting. So those two equations are, there's one that passes through, you can see here at 2, the other one that passes through negative 2. So what we do, we find the slope of both lines at the same time. So you can see they all have the same slope at -1. Okay, so let's look at the next problem. So as the next one, we have sin xy equal x plus y. Just to avoid confusion, let's say we need the whole product here, because otherwise it can mean something else. Okay, now again as before, differentiate with respect to x. So this is a sine, and we know what's the derivative of sine. So derivative of sine is cosine. Derivative of cosine is not sine, it's negative sine. It will be very clear if you look at the graph of the functions. Okay, so if you take the derivative with respect to x, now what you get is it's become cosine, the product, and then multiply by the derivative of the product. This we did multiple times. It is x y prime plus y x prime, which is 1, equals to, on the other side, 1 plus y prime. Now what we do next is see whether there are any common factors to cancel. No. So what we do is we distribute, and then we also write those xy terms in front. So we can write this one as xy prime cosine xy, and then y cosine xy equal 1 plus y prime. Now we're going to bring the prime terms to one side. So if you bring the prime terms to one side and factor y prime out, you can see that this is y prime x cosine xy, and then minus 1, because y prime, when you bring it, is minus y prime, so you're going to get that. And then also we can move all the other terms to the other side, so switch the sign. So this is what you get, and then we divide by the factor, so it's y prime equal, you can see actually there's a 1 here, so it is 1 minus y cosine xy divided by x cosine xy minus 1. So that's the answer. And you can see that you cannot reduce the number of negative signs even if you switch the sign. So we can leave it like that. So let's look at the next one. As next one, we have e to the x minus y squared equal 5 minus y. So with this exponential function, and we know the derivative of the exponential function is ex, you get ex back. So, so again, differentiating with respect to x. So when you have derivative of e, so we know that we repeat the function and then multiply by the derivative of the inside function, which is 1 minus 2y y prime equal on the side 0 minus y prime, and then distribute. So e x minus y squared minus, we write 2y y prime in front, and then we have negative y prime. Bring the y prime terms to one side and factor out y prime. So you're going to see that 1 minus 2y e to the x minus y squared, and if you move the exponential term to the other side, it's going to be negative e to the x minus y squared. So y prime is, if you divide, is negative e x minus y squared divided by 1 minus 2y e to the x minus y squared. Okay, and then you can see that there are two negative signs for this one. So if you multiply the top and bottom by negative, you can rewrite this one as e x minus y squared over 2y e to the x minus y squared minus 1. So this is much better than the previous one. And also, if you multiply the top and bottom by ey squared, you can write this one as ex over 2y ex minus ey squared. So you decide which one is better. I think like this one would be much better compared to that one. But there are a lot of versions of that. Okay, let's look at the next one. So we have xy equals 3. So these kind of questions, equations are common. So these are what we normally call the rectangular hyperbolas. So that means this is the equation of a curve like this, like that, and like this. You can see when one increases, the other one decreases. and also the product is a constant which is equal to 3. So what we're trying to do here is like we try to find a slope at a point like that. So what is the slope at that point? It didn't go through well. So like that. So we can find the slope at a point like that. Okay. Good. So how we do this? We can just use the so we can do this problem in two different ways. You can write this one as xy equal 3. So that means y equal 3 over x. Now this is an explicit equation. So you can just take the derivative of this one using the either quotient rule or just the power rule. If you use the power rule, you can write this one as 3x to the negative 1 and use the power rule. But here we try to use the implicit differentiation and see how you do that. So again, if you differentiate with respect to x, this is the product, and we know the product rule. So it is x y prime plus y x prime equal constant is 0. So that means y prime equal, you move the y terms to the other side and divide by x. So it's going to be minus y over x. Okay, so let's do one last problem. How about this? So we have x squared plus y squared equals z squared, x squared plus y squared plus z squared equal 25. What is this? And you can see that this is actually represent a sphere in three-dimensional space. So that's a sphere in a XYZ coordinate system, x, y, and z. So what we're trying to do is we try to find the slope at a point on the surface. So let's say like something moving on this surface. So and then we try to find the slope at a particular point. Like if you just pick a point, and for example, let's say here, what is the slope when you move at a particular moment? So you can see you can draw a tangent line. It's actually a tangent plane. But if you draw parallel to the curve as a tangent, you can see find the derivative. That's exactly what you're trying to do. So let's just another problem. Let's start with the derivative with respect to time now. Let's say it's going to move on time. It can change on time. So what we can do is we can take the derivative with respect to time. You can do like any variable, but let's see what will happen. So what we're going to do is differentiate with respect to time. With respect to time. So that means the variable is t. So what we're going to do is, if you take the derivative with respect to t, it is x. So we do the x first, and then multiply by the derivative of x with respect to time. Again, 2y, we have dy over dt, plus 2z dz over dt. Constant means 0. And then you can cancel 2. What we normally do is, and then you can see you get equation x dx over dt plus y dy over dt plus z dz over dt. So if you know 3 of them, and then you can find the others. So for example, let's say you know these two and those two and one of them, because we can find z using the formula. So that means if you are given 4 of them, you can find the other one. So you can find this one. So that's what we can do. Okay, so now you can try these problems as practice. Now try to find the derivatives of the following functions.